Good morning and welcome to Advent of Code in F# day 23. We left day 22 with a solution that was running for quite a while, but actually it solved the problem. It only took, 45 minutes, which is not really good, but it worked. But later in the day, I saw someone else solve it in F# as well. So I was really interested in how Ralph solved today's puzzle. And he did very similar things, but there was one very interesting difference, which is in how he keeps track of all the previous states. So he doesn't use a list, he uses a set. And I was like, So I did some research, and sets apparently are implemented using binary trees instead of a list. So that means that when you insert stuff into a set and when you search stuff in a set, like does it contain this state already, it's way faster. It's like, yeah, it's way faster than when you do it with a list. So I reworked my example, which takes 45 minutes to run, and if you run it with a set, it takes 10 seconds to run. So yes, data structures matter. So yeah, that's day 22 solved in 10 seconds instead of an hour. Let's take a look at day 23. Crab cups. Oh, the crab is still our friend. It's the street game. Crab cups. Okay. Cups arranged in a circle, labeled clockwise. Okay, so our input is the labels of the cups. 3, 2, 4, 1, 5. Going clockwise around the circle from the first cup, the cups will be labeled as 3, 2, 4, 1, 5 and back to 3 again. So we have a circular buffer. I think data structures will be important today. Let's keep reading first. Before the crab starts, it will designate the first cup in your list as the current cup. Okay, so we have a current cup, and then it's going to do 100 moves. It has 4 options. So we have a current cup, and then 3 cups after it. Removes them to maintain the circle. Okay, so we just extract 3 cups. Then we select the destination cup with a label equal to the current cup's label -1. So if we have current cup 3, we look for current cup 2 and put the 3 and we do something. Okay. If it's just picked up, keep going further down until you find a cup that was not picked up. If we wrap around, yeah, it wraps around to the highest value. Yep. The crab places the cups it just picked up so that they are immediately clockwise to the destination cup. Okay, so we insert them back into the circle, immediately following the destination cup. And we keep them in the same order. That's perfectly clear. And then we tick on to the next cup. Okay, example time. So that's how we indicate current cup. Cool. We pick up 3 next ones. Yes, we are at 3, so we should be searching for 2, and we insert them. I've already seen this puzzle, I think. It's a flashback to a previous puzzle. Do we have an example where the current cup? Yeah, here we pick up 1, and 1 is not in there, so we should be picking up 0, but it's not there. So 9, but it's not there. 8, no, not there, so we should be putting it at 7. 7 is here, so we just paste 8, 9, 1 at the end. Yeah, this makes sense. After it has done 100 moves, what order will the cups be in? Starting after the cup labeled 1, collect the other cups labels clockwise. Okay, this is just how we munched the results. Okay, we even have the 100 moves example for the small result for the small example. Cool. 100 moves doesn't feel that bad. Let's. Oh, especially not with an input like this. I get the feeling that part 2 might be expecting a bit more of us. I'm not gonna read the file for something this small. Let's think here. I think part 1 we can just brute force through. Part 2 might require us to think about data structures. Should we be thinking about data structures, or should we just list it? Let's just list it. Let's see how much is expected of us. So, let's parse this into a sequence of numbers. And let's keep our keyboard layout. This is not what I was expecting. Oh, come on. This is what? The car value? Are you kidding me? We've been solving puzzles for 3 weeks in a row and I suddenly forget how to parse integers. Will it work if it's a string instead? Probably that's the problem. Yes, it will. Okay. So let's first map them to string and then to int. It's only 10 numbers. Don't shoot me. That's better. What's our data structure? We keep track of the current cup. Will we always assume it's just the first one in our list? Or is that a bad idea? No, if we use list as a data structure, that's the only way to keep it somewhat performant. So, first element is the current element is the first one, and then we can just play the game. So, what were the rules again? Current cup, take the next 3. So, what's it called? 100 move. So let's write a move. So we have current rest. Let's destructure this. And then we need what? 3? Yes, let's just, I don't know if it's a good idea, but let's just destructure like this. Now we have the current cup and the next 3. And then we need to find the lower cup number in rest, like 1 lower, and if it's not in there, or if it's one of these 3, we have to go even 1 down. So, what's it called? The next cup? Destination cup. Should we... It's not that long a list, so I don't know if we should be worrying about performance. I'm thinking like we can check if it's 1 or 2 or 3 instead of checking if it's in the list. Can we find the index of something in the list? Find the index, yeah. Or should we just plop it in with recursion? Yeah, if you're working with lists, you can't just insert stuff. You can't just insert stuff. There's no function to do that, I think. Could do something with a map and then play around with... Yeah, you can do something with a collect, I think. To insert something at a specific index. Yeah, if you map and collect, but my brain has not warmed up yet today. Anyway, we know the destination cup. No, we don't know the destination cup. Could be that we have to subtract even more, and we're not doing the looping around if we hit max number. So let's do that first. If a number is 0, or we just do modulus the biggest number, right? Is max a thing? Yes, max is a thing, so let's call it maximum. It should be 9, right? Right. So if we do modulus 9, we should end up at 1 again. Or at least that's what I'm trying to do. 9 is okay, sorry. Wait, so just a number is the number. And if we hit this number, it should also give the number. Oh, I'm having a tough time with basic math right now. How do we loop 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9? Problem is that modulus stuff works with 0, so we need to do 1 plus something. If we have 9, so this needs to result in 8. How does this result in 8? Oh, come on. Or is it is this 0 modulus 10? Yes. If this is 7, we should get 7. Okay, this works, but is this the most efficient way? Don't care. So this is maximum, and this is the number. So this is just a little function to keep wrapping around our universe of, or our domain of the numbers. So we subtract, and then we look if it's in the list, and then we wrap, and we are good to go. Yeah. Pop, 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 pop. Let's do. It's too hard for my brain to wrap around it, so let's find destination given the current and the, what's the 3 cups called? Let's call them the selected cups or something like that. So if selected if it's already in there, let's just recurse with current -1, but we wrap that around and otherwise current is just fine. What? Oh yeah, we need max. Sure, let's get max inside the thingy. There we go. Okay. There we go. So this is just find the destination, given maximum, current, and 1, 2, and 3. So then we know where we have to place the cup. Do we? Yeah. And now we have to insert after destination, but also do the circular thing. I know Golang has a good data structure for these kinds of problems. Shout out to Golang, Alex. Circular buffer, was that the ring? That's what it's called. So yeah, this will be way more efficient than working with a list than what I'm trying to do here. But digressing. We know where to place it. Let's drop them in. How do we do this when we have to wrap around the end of the list? I'm thinking about the map and the collect thing. So we go over every element, but if we find the index, or if we find in destination, then we go. Can we list split at the index? Yes. Okay, that's maybe even better. So let's find the index. Index is always in there, sure. So then we know where we have to plop things. And how does this handle the wraparound thing? So it can be 0, anything, or it can be the last element. And if it's the last element, we need to plop our numbers in the front. Otherwise, we just put it in there. So what does this mean in split land? Let's first split. So if this is anything between 0 and the length minus 1, we can just plop the numbers in there. If it's the last element of the list, then we need to prepend the list with current 1, 2, 3. What happens with the current cup in that case? So we are doing this, finding destination cup, minus 1, and you keep going until you find one that's in the rest of the list. And then when you place them immediately clockwise of the destination cup. Okay, so we don't actually pick up the current cup. Current cup stays in the circle. Current cup stays in the circle. So we know where we have to insert. If we know where we have to insert. If it's the last one, so if it's length minus 1, then we have to put what? int list. It's confused. Wait, let's do something first. Let's return cups. We're good? No, we're not good. What's happening? Destination int bool. What? Find index is not doing what I thought it would. So it gives. Okay, this is more generic than find the element in the list. Okay, no problem. So this will find the index of the element that equals destination then. Okay. So if we're at still length is an int, how can I not? Oh yeah, split is a what? So these are two lists. Okay, I'm thinking about indexes, but that's this. Okay. So actually I'm doing this. Could we do it with the split thing? Yeah, let's do it with the split thing. That makes more sense. So if you split a list into two sublists, if the list is actually it doesn't matter if we does it matter? Do we have to like move to the front? No, we can just paste to the back, right? Where's the example where, for example, the destination is the last element? Here it is. Yeah, we just paste it to the back. 891 paste to the back, and that's it. I'm making it way harder than it should be. Why, oh why? Yep. So let's call this before and after. The only thing I'm not sure about is this current. Maybe I should include current in the whole shebang. Yes, we should. I got a gut feeling. So we'll treat the list as, or the cycle as everything except these three. And here as well. So we split, we insert before 1, 2, 3 after. So I think this is okay. And so this is a single move. Let's wrap this thing in a function because we have to be calling it a lot. Yes, I don't want to do this the whole time. So this is just a recursive tail recursive call. So we move our cups. If we don't have to move them because we're out of moves, we're done otherwise. This is the next, and we move again. No? What? Oh yeah, we have to call the function. There we go. Let's try it out on the example instead of on our input. Let's do 10 moves. Maybe not shout at the computer. 239. Oh, that's totally incorrect. Great. Let's print out what we're doing. What are we not doing correct? So already ends badly. Oh yeah, we should be printing out current. If we want to keep track, like the example. So we have current. What do they print? Cups. So cups. Destination. Oh, I hate it when I have to sprinkle everything with print. Yes, you could use a debugger. Yes, it works well in Visual Studio actually. We tried it a couple of days ago, but I don't feel like booting up the debugger. So this KKK current is always our first element. Actually we want to print cups. Current, that cannot possibly go wrong, so cool. Maybe clean up our output. There we go. What are we doing wrong? Cups. Yep. Destination is 3. What? That's not correct. What are we doing wrong? Yeah, we are calculating destination wrong. So that's a simple modulus thing. How am I? Okay. What are we doing? Find destination maximum given the current. Current here is not alright. It should be current -1. That's our starting value. See if this fixes it. That's better. So do we end up with 389 dick? No, we don't. 389 is still the input string. So 389 destination is 2. We pick up 891. But that would mean that 891 end up after the 2. Yes. It's not doing a good job at inserting. Split will split at this number. And we're inserting it between, yeah, split at is not doing the thing it's working correctly, but it's not doing, in my head it did something else. So for example, split into, what is that? Split into, that sounds like not something we need, but I'm interested. Okay, splits into 3 lists of somewhat equal length probably. Let's start at 0, that's easier to understand. So if we split at index 3, yes, then index 3 is in the right part. So we should actually split at 3 plus 1. Then we're splitting correctly. Yes. Okay. Where are we splitting? Destination index plus 1. Should we wrap this? Probably. We'll see what the example tells us. Or what? Oh yeah, max. Let's go. Nope. So we were not sure about this wrapping thing. Let's get rid of that first and see what's actually happening. Okay, still not. Destination 0, yeah, that will never work. So that should be wrapping. Wait, this if we're trying destination 0, that means our find destination is not really working, right? So we pick 3, 1, 2, and 8, and then we need to find 2, it's not in there, 1, it's not in there, 0, this should be wrapping around. So find index, find destination. We're working with 2 and we get 1, 2, 8. This should return max. Where is max? It's front. So our max is 9. This should return 9, not 0. Yet another bug. Selected contains current. That is very much the case. So find destination maximum. Current minus 1 is 1. Okay, then we do recursive call. If 1 is in the list, which it is, then do the same thing with 0. Oh yeah, this is, yeah. It's 0 already. Yeah, okay, this is wrong. So wrap. It takes an incorrect number. So if we have 9 as a max, and we have 9, this should return 9. That's correct. If it's 1, it's 1. But if it's 0, we should like 1. Right? No. 1 is a correct value. 0 is not a correct value. 0 is definitely not a correct value. There's a better way. I don't see it. It's something stupid with 1s and 0s and modulus. Not seeing it, but this will work. Let's run our test again. Yeah, that's better. So 3, 1, 2, 8. Oh, come on. Okay. I have the feeling today would be, or part 1 should not be this hard. My brain is feeling the toll of 23 days of puzzling, I think. Destination 2, so we put our 891 after 2, that is correct. Then destination is 7. Oh my god. Oh yeah. Our current cup isn't moving. Our current cup isn't moving. Our current cup isn't moving. Oh. What happens with the current cup? Should we keep it in the front? No, because our assumption was that the current cup is always the first element. So we should throw our cup to the back of the row instead, actually. This is not okay. Should we throw it at the back? Yeah, let's try it. We're shuffling things around. We that are not in the example. Oh boy. Did this just start crashing again? No. What was crashing? Nothing's crashing. I saw an error. Yes, I saw an error. Oh, not this again. 273. Yeah, now it seems to be working, but destination 0 again. So yeah, we need to figure out the modulus thing because that's a strike 2. So current is 1, and then we have 367. So it would try to find 1 minus 1 is 0, so we should again wrap around. Right. Why is it saying destination 0? It should never return 0. What? The first thing I do is if it's 0, if it's 0, then return max. How can this ever return a 0? Oh, sorry. Yeah. Oof. Oof. Come on. I think I need a power nap. Okay. Okay. 837 something something something. 837 something something. Ending in a 5. Yes. Whew. So this is the example. How do we calculate the score? We find the cup labeled 1, collect the other cups into a single string. So find the index of 1 and paste everything together. So if this is it, we should have 92658. Cool. So if this is the current, actually let's grab our representation, that'll work better. Should be the string this. There we go. Okay, so find the index of 1. I think we can do a split trick again. So and then yeah, let's do the split trick again. What do we need? Just make a big number of it. So except the 1, that is true. Where is the so let's just split at the index. We're gonna have to take care of where does 1 end up if we split? Where was it? It was the first element of after. It was the first element of after. So this will crash very hard in a specific case if after is the empty list. But let's figure that out when we have to. So this is not fail-safe code. I don't care anymore. My brain is too fried. How? How did destination start breaking again? Because it's a false statement. There you go. KKK. So we move our cups. And we score our cups. Nine, 2, 6. Yeah, that's correct. Let's do 100 moves. Cat. An index satisfying the predicate was not found in the collection. We're actually not doing this much of moves. We're like only doing what, 11? I saw 9, and 9 was in the beginning of the string. Seriously, am I not taking care of that? So if these are the cups, destination should never be 9 again. Oh my god, my find next number is totally failing. Okay, let's draw this out. Or let's type this out somewhere. Code? Yeah, sure, code. So, given this, cup is our current number. These are the 3 next. So we should look at. We should be looking at not 9 but 8. And we're getting back 9. For some reason we're getting back 9. I can't believe this one line of code, and it's always with the 9s or the 0s. My modulus thing is incorrect. So destination. Oh yeah, so this gets 9, and then we have 9 to 6. You know what? This is how it works, right? We subtract the number and we give it a find destination. Yes. So old cases work. This is failing. It's not failing. This looks exactly as what I expected. If we find 9, but it's one of the 3 next numbers, we should have 8. That's actually what's happening. What? Okay, let's print how we figure out destination. Now maybe debugging would have been faster actually, but okay. Okay, so yeah, I was looking at an incorrect example again. Oh, my brain is not ready for a puzzle. Figuring out destination given 9, 0, yes, and 9 to 6. It's again this 0 case. Oh yeah, of course. I do the shortcut, or the I don't want to figure this out. I just hardcode 0. I just hardcode 9. But 9 can be one of those. That can be one of those. Oh, I'm making a mess of things. I don't understand what I'm doing. That's not a good idea. Yes, I have some tests to back me, but so yeah, that's actually the same as this. I think that's more correct. No, it's definitely not more correct. Why are you not working, coffee? So there's actually only, what, 5 lines of code today? It's basic maths. Just loop around. Okay. Okay. Do not despair. We are given a 0 already. Is a 0 actually something we want here? It's not a valid number, so no, that's not something we want. So actually, we should be doing the wrapping here. Now we're doing too many wraps. There you go. We're doing way too many wraps. But it's like not a problem to do a wrap too many if that's not performance issue. Okay, this works. So we're doing wraps too many. This is, I think that's not the easiest way to do it. I think we might even get rid of this wrap now. So also this wrap. If you just wrap every time we call this function, it'll be good enough. So there and there, yeah. Cool, cool, cool. I think this would still work. Yes. Okay, I'm happy enough. I'm happy enough, so let's grab our input. And let's go. So, a bit of a stumble through today. And I hope part 2 will push us to the limit performance-wise, so I have to look up some data structures. Haha! Oh yes, it does. Okay, so we have 1 million cups instead of just the 10. Many cups are numbered in increasing fashion, starting from the number after the highest number in the list, proceeding 1 in 1 until 1 million is reached. Okay, so the next numbers are just 10 and up. Every number for 1 to 1 million is used exactly 1. Yes, that is clear. And then it's going to do 10 million moves as well. So yeah, we need a more performant data structure. We need a ring or something ring-like in F#. I'm just gonna watch it burn, or watch it make my computer burn, and then I'm gonna cut the stream because this was not the most productive morning. Let's first just try it. So, part 2. So we don't need 100, but we need 10 million moves. For readability, let's introduce some separators. Yeah. And parsed is not what we want. We want to make parsed a bit bigger. So this is parsed, it ends at 9. So from 10 to a million. Will a million fit in an integer? Yes, it does. So actually this is not the list, but 10 to a million. Does this look correct? 9, bop, 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 and then 10 and onward? Yes, this looks correct. So it's the full list, it's the full list. And this will quite certainly. Wait, what? The crab is going to hide your stars under the 2 cups that will end up immediately clockwise of cup 1. You can have them if you predict what the labels of those cups will be when the crab is finished. Oh, so we don't actually have to do it. We just need to predict what the labels of the first 2 crabs are. Predict. Is this like a subtle, not so subtle hint as to you don't actually have to play the game millions and millions of times? Let's print out every million moves we have. So but I know now already that working with lists is not a good idea. There we go. So this is naive old me trying to do 10 million moves on a 1 million cup list with a list, not a ring. Yeah. Oh, stop. We're printing. Printing will drag it down even more. What? How could there have been 1 million moves already? That's not. Oh yeah, it starts at 10 million. Sorry, we're counting down. Yeah, this will not work. We will have to think about our data structures a bit, which is what I will be doing when I'm having my breakfast. So I'll see you later today.